on my channel. So in this today we will try to solve Leetcode problem of binary tree in order traversal. So this is a problem number 94 on the Leetcode, and basically we will be solving this. So here if the problem statement is given the root of the binary tree, then we have to return the in order traversal of its values. So let's first try to see what is in order traversal. So here we can see we have a binary tree. So a binary tree is a tree with having only two children, left children and right children. So as we can see that this is a binary tree, so we will try to do first in order traversal of this binary tree. So what is in order traversal? So in order traversal we first visit the left, then the root, and then the right child of a binary tree. So for 1 the left is 2, and for the and 3 is the right child of it. So in any given case, suppose if we have a binary tree 1, 2 and 3, and if we want to do an in order traversal of it, we will first visit the left child of it, that is 2. Then we will visit the, since it does not have any left child, so we will be printing 1, the root, and then we will be printing 1, 3. So this will be the in order traversal for this simple tree. So now let's see a complex example. In this we will consider the in order traversal of this particular tree. So as we can see that first we need to visit the left. So we will start from the root node. So we will visit 2. So 2 also has a left child, so we will visit left, the child for this. And 4 does not have a left child as well as right child, so we will be printing 4. Now since we have visited 4, now we will track back to 2. So in 2, if we see that we have visited the right child of it, sorry, the left child for it, now we will see it does not have any left child, so we will be printing 2. Post that we will be visiting the right tree of it. So right is 5, and 5 does not have any left child or right child, so we will be printing 5. Now again we will trace back for 2. So 2, both the childs has been covered, even 2 is also covered, so then we will track back to 1. So 1, all the left child is covered, so we will be printing 1. Post that, now we will be going to the right child of it. So the right child 3 does not have any left child, so its left tree is covered, so we will be printing 3. And post that we will see that it's right, it also has a right child, and right child does not have any left or right child, so 6. So now we have visited all the nodes of the binary tree. So this is our in order traversal of this binary tree. So 4, 2, 5, 1, 3, 6. Now let's see the code for it. So we will be solving this problem with the help of recursion. So recursion is a method in which the method calls itself. So this is the solution for it. So let's go through the solution one by one. So here, if we see the solution, we have to return a list of integers that will be basically the in order traversal for it. So if we see, the in order traversal is calling an in order method that is doing the recursive approach and filling this list. So here in order we are passing the root and the list. So if the root is null, we will be returning, we will not be doing anything. If the root is not null, then we will be returning the left, calling the method itself with the left and then the list. And if that is returned, then we will be adding the value of that, and then again we will be doing the right child of it. Let's see it via the, here is our tree. So the statement was that first do in order of root dot left, we have to print root dot val, then we have to again do in order of root dot right. So let's see. So first we will be starting from the root node 1. So our root currently contains 1. And as we know, recursion, it uh, keeps a stack of the visited node. So let's see. So 1 is there. So now we will be visiting from 1 to the left child of it. And here also we have a base condition. If root equal to null, then we have to return. So left child of it. So we will be storing 1 in the stack. Then we will be visiting the its 2. So 2 is also not null. So again 2 will be stored in the stack. And then again we will be visiting the left for it. Then again 4 will be stored in the stack. So 4 left will be gone. So the left for it is null, so it will be returning. So we will be having we will be printing root dot val. So currently in the root it is 4, so it out, and we will be having 4 here. So 4 will be printed. So now 4 is popped out from here. Now again if we will see 2, so now 2 is there, so 2 is also done. Then again 2 will be popped out here. So 2 will be popped out and printed here. Again what we will be doing, we will be visiting the right child of it. So 2 has a right child of 5, then in place of 2 here 5 will be added. And again what we will see, again 5, the left will be null, it does not have, and then 5 will be printed here. Again the right is also null, so it will be returned and it will be popped out from here. So now again we have 1. So 1, again we will be printing 1, so 1 will be popped out from here and it will be going to the right child of it. So right child is currently 3, so 3 will be inserted into the stack. And again we will be seeing it does not have any left child, so here from here it will be again returning null. So here again we will be popping out 3 and putting it 5. Then root dot right is again 6, so we will be adding 6 here. And then 6, again it does not have any left or right child, so again it will be returning and 6 will be printed here. So this is how the code will work. And 6 will be again popped out. Now our stack is empty and this will be our in-order traversal for this tree. So now let's try to execute this code in Leetcode. Now let's try to submit the solution and see. So let's run it for the base test case. So it has passed. Now we will try to submit it. Yeah, so it has passed all the test cases. And also please note down that the runtime complexity of this solution will be O of n, where n will be the number of the nodes, as well as the space complexity will be O of 1, since we are not using any additional space. And if we consider the stack memory that it is taking, then it will be the space complexity will be O of h, where h will be the height of the binary tree. Thank you. Please like and subscribe to my channel.